dimensional objects. These are our objectives for this chapter of today. Here you will come to know about the architecture and operations of two-dimensional graphical system. You will also understand the 2D coordinate system, and also you will see how we will be able to write a 2D Java 2D program. So here you will come to know about everything, how we are going to use this 2D graphics by the help of Java. Finally, you will come to know about how we are using this general path class and how we are going to construct some geometrical shapes. So here we need to understand about the geometric objects, 2D geometric objects, what they have. So we have something, we call them points, okay? Every point is having two coordinates. So I'm showing you here the basis of 2D geometric objects. You must remember that in every geometric object, we have many things. Number one, we have points, we can have lines, we can have areas, we have many things, okay? So now what is a point, okay? Every point is represented by two coordinates, x coordinate and y coordinate. For example, when we are saying that x is a point, or A is a point, or B is a point, or P is a point with the coordinates, for example, 3 and 5. Okay. So what is 3 and 5? 3 is the x coordinate, y which is equal to 5, 5 is y coordinate. So every point will have two coordinates. This can be a multiple choice question in your exam. For example, there is a point, it contains x and y coordinates. About the lines, with the help of these points, with the help of points, what you can do, if you have two pointers in any graphic system, if you can join them and you can draw a line. So that means in order to draw a line, you must have these 2 points. It can be, for example, point 1 and it can be point 2. If you have these 2 pointers, you can draw a line, okay? And every point will have x and y coordinates. So that means every point is having 2 coordinates and every line is having at least 2 points. After that, what you can do, in the same way, you can have many lines with, for example, 2 points, and then you can have a line from here, you can have a line from here, okay? And then you can join them in order to make a polylines, in order to make polylines. Or sometimes you can draw any lines in different ways. For example, like this, here is a line, and then you will bring it down, and then you will make it like this. You can make a type of curve by defining these points like this, okay? So now, whenever we are going to draw any of these lines, we are going to draw any of these lines, we say, and we are using any polylines in order to draw, for example, any graphic object. However, we have also other graphic other types of lines. We call them curves. Okay, these curves, if you are going to see here, they are only the straight lines. But sometimes the curve is like this. Okay, so what you are going to do in this curve, you will find one more extra point. This is the start point, this is the end point, and here will be one more point. We call it control point. Now it depends upon the type of curve. Sometimes the curve can be like this, and sometimes the curve can be like this. Here, if we have this type of curve, we call it chord curve, and here we have only one control point. While as in case of cubic curve, we do have two control points. One is here and another is here. Okay, so these control points shows us that how much you are going to stretch any given line. After that, for example, if I'm going to draw one line now, for example, like this, okay, what you will see here, you will find here, you will get a type of area, okay. So now, whenever we are going to drawing geometrical objects with the pointers which is having x and y coordinates, and then we are going to have, for example, at least two pointers, we can draw the lines, we can draw the polylines, we can use more than 2 pointers, for example, the additional control pointers in order to draw the curves. Curve can be chord curve or it can be a cubic curve, and after that we can see, we can find the area which can be bounded by the closed polylines or polygons like here, okay. So now in this way, what you can do, if you have, for example, this area you can fill with a color or you can use any other texture. For example, here I have used a type of texture or I can fill it with a color, okay. So you understand here what are pointers, what are lines, what means polylines, what are curves, what types of curves we can have. It can be chord curve, it can be cubic curve, and then what are the areas? Area is actually the bounded closed area which you can color, which you can fill by a color or by a texture. Is it clear? Now you can see here, sometimes we have polygon shapes, okay? What is a polygon? You might have seen that in geometry we do have different shapes. Every shape depends upon the number of corners or number of corners or number of angles. For example, let me take, for example, this shape. What we call it? We call it triangles. Huh? Okay, how many corners you have here? You have 3 corners, 1, 2, and 3. If I am going to take another shape, for example, like this is the rectangular shape, okay? Rectangle, here we have 4 corners. We can have another shape which is square, there can be also 5 corners. We can have a shape like this in which we can have more corners, 5 corners, okay? So now, if there are 3 corners, we call it triangle. If we have 4 corners, it can be, for example, square or a rectangle. If we have now more than 4 or 5, we call it polygon, okay? Polygon means, poly means many, gon means angles or corners, okay? So now in this way, you can draw a different types of polygon pictures, polygon objects, or polygon shapes like here. These shapes can be begin like this. I want can be type. So these shapes, they can be either convex or they can be non-convex. Now you need to understand what is the difference between convex and non-convex shapes, okay? Now let us suppose that I'm going to take example of this shape or this shape. Let me explain first of these shapes. If I'm going to select any point within the region of this shape, okay, and then if I'm going to join them, let me join, for example, these 2 points, okay, this point and this point, or you are going to join these 2 points. or you are going to join these 2 pointers. If you will see all the pointers in this line, they lie within the region of the shape, then it is convex. Okay, then it is convex. Now here we do have a polygon with many corners, 1, 2, 3, 4, 5, 6. Okay, 6 angles are here. So now let me take 2 points. This is the first point and this is the second point. If I'm going to join them, for example, here, if I'm going to join them, okay, all the points in this line, they are within the region. But what about this line? You will see here some of the points of this line, okay, it becomes out of the region of the shape. When it comes out of the region of the shape, you will say that it is non-convex. Okay, so the same is going on here. If I'm going to, for example, see here, if I'm going to take 2 pointers within this region, yes, it is convex. Here I can say it is also convex. Here it is also convex. Okay, but what about here? If I'm going to join these 2 pointers, you will see that this line, it goes out of the region of the shape. Then here you can say that it is non-convex. So we understand that if you have a convex and you are going to take any 2 points within the region and you are going to connect a line between these 2 points, if it completely lies within the region, then it is convex. Otherwise, if it is going out of the region, then it is non-convex. So now for convex, the condition is all the points of this line must lie within the region. That is convex. Otherwise, it is non-convex. Now here you need to understand some more concepts when we are going to draw any shape, when we are going to construct any shape, any geometrical shape. Okay. So now here we do have graphic objects. Okay, how we are going to construct these graphic objects? We are going to construct them by the basic primitives. Okay, what are those basic primitives? It can be a line, it can be a polygon, or it can be ellipse. By these basic primitives, we are going to make any graphic object. So now here, what we need to do, we need to include the object. For example, sometimes the object can contain the text as well as the image. After that, we can use the transformation. Okay, the transformation, we need to construct the model, and the model can include the text and the image. After that, we can perform transformation, which is included in the 2D graphics. And what type of transformation it is? It is actually a set of transformations, and we give it the name as affine transformations. Now, if you remember in the last tutorial, we also told about the object transformations and viewing transformation. Object transformation, as I told you that in affine transformation, there are actually 5 types of transformations which we are going to apply on the objects. Then what is going on? This object transformation, it can change the shapes as well as the position of the object and the location of the object, okay, or the position of the object when you are going to apply the transformation. What is viewing transformation? Viewing transformation is not going to change the virtual world model, but it can change only the view of the entire scene on the world space. So what does it mean, or how you are going to understand it? Let us suppose that in our virtual model, we have, for example, a circle and a triangle or a square or a rectangle, okay? And if you are going to apply a translation, then what is going to do, if you are going to apply the translation to a circle, okay, then what is going to happen? It is going to change the object transformation. So what does it mean? It means that it is going to move only the circle without changing the other space, other shape. It can be rectangle or triangle. It is not going to affect it. However, if we are going to use a translation and a viewing transformation, it is going to move the entire view. Yani all the shapes, it is going to move the entire view, means the circle with other shape. Okay. Now here the second point is which you need to understand in two-dimensional graphics, that is the 2D coordinate system. You also know that how, for example, when you are going to draw the graphics, you know that we do have x-axis and we have y-axis, and here it is the origin, okay, and the coordinates of the origin are always 0 and 0. So now here for this quadrant, here the x will be also plus, y will be plus, and for this quadrant x is plus, y is minus, and here x is minus, but y is also minus, okay, and here it is minus x and it is plus y, okay, no, it is minus x plus y, and here it is x minus y, okay. So now in this way we are going to do it. We are going to draw, for example, any shape based on this coordinate system. So now what we are going to do, we are going to see what is the value of the x, what is the value of the y, and based on the coordinates of this graph, we are going to decide where we are going to draw it, okay. Now here, if you have to draw, for example, a line, okay, there is an equation, okay, a linear equation, which is going to define, for example, a line. For example, if you have ax plus by plus c, it is equal to 0. It is the general form. However, if I will say, for example, we have an equation like this, 2x plus 3y minus 5, it is equal to 0. Okay, so I can write it as 2x plus 3y, and then I can say it is equal, for example, plus 5. So what you are going to do here, you will make a table like this, okay, and here you can say, I can say, for example, 2x is equal to, for example, 5 minus 3y, okay, and then divide both sides by 2. This 2 will cancel, it will be divided by 2. But then you will see here x and y. You will give any value to y, for example, here whatever you like, 0, and you will get, for example, x, up to you. Or if I'm going to solve it for y, then I can say y will be equal to 5 minus 2x divided by 3. So now again the table, okay, find the value of x and y, put, for example, x is 0, you will find the y, and then you can draw the line. Now, in the same way, there is an equation to draw, for example, a circle, okay? You know what is x, you know what is y, and that will be equal to the r square. R is here a radius, okay? Now, let's suppose that if you are going to have any radius, for example, 5, so you are going to start from the origin, taking the radius 5, and then draw the circle, okay? Another equation is for ellipse, okay? Here for ellipse, you need to know that it is x minus x, x minus x0 square divided by a square plus y minus y0, y minus y0 square divided by b square is equal to 1, okay? So now here in ellipse, one side will be greater than another side. So what does that mean? It means that A is greater than B, okay? Then it will be ellipse. Otherwise, if A is equal to B, then in that case it will be again a circle. Okay. Here, do you have any question? Any question? Okay, so now let's continue. Now we have some equations, we call them parametric equation. What is a parametric equation? In parametric equation, we are going to use a third variable. Okay. In previous equation, as you can see here, we are going to use only two variables, x and y. Here also x and y. Here also x and y. But in parametric equation, we are going to introduce, we are going to use one more variable, which is the third variable, not t. How? We are going to express, for example, x, which is a function of t, and f of t, while as y is another function which is written here, g of t. T is actually the third variable. X, y, and t is the third variable. So now, what is the parametric equation of ellipse? Okay, here you need to remember that x is equal to x0 plus a cos t, whereas y is equal to y0 plus b sin t. Okay, so what are any x0 and y0? If you will see from the picture, you will see here that x0 and y0, that is the center of the ellipse or the circle, where from you are going to draw the picture. You can draw it from this center, or you can draw it from anywhere in your graph. Okay, if you are going to draw it from anywhere, then x0 and y0 will be the center of this object. Now about the spaces. Okay, what we are saying that the collection of all points or coordinates, we are saying that it is known as the space. We do have three types of spaces. And space means the collection of pointers, of all points and coordinates. And we do have three types of spaces. Either it can be object space, word space, and device space. What is an object space? It is generally characterized by its own coordinate system. Okay. For example, it is also known as the local modeling or modeling coordinate system. Local and modeling coordinate system. The object space is associated with definition of particular object, particular graphic object. Okay, if you are going to construct, for example, the object, it will be convenient to choose the coordinate system which can be natural to the object. Yani, in object space, it includes the collection of all the points and coordinates of the object which you are going to draw. Suppose we are going to draw a circle, okay? Then what we need to do? We need to choose what is the origin of the coordinate system of the circle. That's actually the center of the circle, okay? And then you need to define the radius, and that will be the coordinate object space for the circle. Now about the spaces, okay? The second type of space is world space. World space means the user coordinate system, which we are going to define. Okay. So in world space, you need to define the common reference spaces for all the objects in the graphic model. And then the the geometric objects, they can be placed into the space through the object transformation. This object transformation you will come to know in the next tutorials. Finally, the third type of space, that's called the device space, which represents how you are going to display your graphic object on the screen, and for that you have a type of space, we call it display space, which is used in case of output devices. Either it can be screen or it can be the printer. If you are going to use any device space, see here the coordinate system changes, okay? The coordinate system changes. It is not same as before, like here. It is not same as here, okay? So now, if you will see here, our left top corner, of the screen is the origin of the coordinates. And the origin coordinates will be 0, 0 here. If you will move in the x direction, okay, then x will change. If you will come down, then y will change, okay. So here in device coordinate system, we are going to use in Java 2D. We are going to use this device space or the device coordinates in this way. As I told you, when you come down, it means that it is y-axis. When you go right, it means that it is y-axis. So in device space, you don't have minus x or minus y coordinates, okay? The coordinates are only x and y. X means if you will go right, and if you will come down, it means y. Is it clear?
Clear, Doctor.
Okay, now.
Doctor.
Yes.
I have a question, please. كل القواعد اللي مرقت معنا راح نستخدمها بعدين؟
Well, I don't understand it. Can you speak in English?
Every rule
أيوة. Try. Every rule is. Hello.
The geometric equations that we just saw, the circle and the other ones, are they going to come in the midterms and finals?
I'm not saying directly they will not come in the midterm or in final, not directly, okay? But in your TMA, there will be some questions in which you need to draw some shapes, okay? And you are supposed to use them, yes. So you need to remember them, yes.
Thank you, Doctor.
Okay. Okay, you will see in the next program, you will see how we are going to use them. But here, it is the fundamental idea, okay? What is, for example, the equation of circle? What is the equation of line? What is the equation of ellipse? You need to remember these things, okay? So later on, because this is graphic 2D, here you need to make some objects. Let me show you here one example. For example, like this, okay? Okay, you must understand this, how you will be able to draw it. That is why these things are necessary. You need to remember these rules. Yes, you need to remember them, okay? Now let us try to understand how we will be use it in Java, okay? In Java, we do have a class, okay? We call it Graph2D class. So in Java 2D, we do have a rendering engine, and the engine which is going to run, which is going to execute these programs, okay? what they do, they are going to access actually a class which is named as graphics2D. This is what we need to remember. However, in early versions of Java, okay, we were having a class for graphics, and in order to draw the graphics, in early versions of Java, we were having one class. It was named as Java AWT. Okay, it was used for graphics. But in new versions of Java, we have another class for graphics. We call it graphics2D. Okay, that is the difference between the old versions, early versions, and new versions. Okay. Yani in older versions, we were having any graphics in java.awt, while as in new versions, we have graphics2D. Okay, so now in order to draw any graphics or in order to construct any graphics, in older versions, you can do it by this class, Java AWT. In new versions, you can use graphics2D. That is it. So now graphics class, what it is going to do or what it has actually the basic methods, okay, for what? For rendering graphics primitives. Graphics primitives means lines, circles, ellipses, polygons, okay. In order to execute them, we need some methods, okay. Where are those methods? Those methods are actually in graphics class. Now, if we are going to use, for example, Java 2D. In Java 2D, we are going to have graphics class. We call it graphics 2D class. This is more enhanced or advanced, or you can say there are more extensive commands, okay, or methods. So graphics this 2D which we use, it extends actually the there is something. For example, if you have written any Java program in which you are going to use graphics in early version of Java, for example, you are going to use Java AWT, Java.AWT. This is the early version, okay, and you want to run it in, for example, in Java 2D, in which we are going to use graphics 2D. Will it run? Will it run? Do you understand the question? You have written a program, a graphics program in Java.awt, and you want to run it in Java 2D using graphics 2D class. Will it run? Yes, it will run, because Java 2G and graphics 2D graphics, it is going to maintain the compatibility between the older and the new classes, and between the Java 2D class and AWT class. Okay. Now we need to understand how we will be able to use this graphics 2D class. Okay. So here, as I told you, we have, for example, graphics 2D and graphics. These are the classes which are abstract. So what does that mean? It means that you cannot initiate them directly. Then how you can initiate them? There are two ways. Number one, you need to obtain a parameter in the paint component method. Like this, you are going to write here, for example, white paint component, and then here you are going to write graphics, and then you are going to declare the variable g. And g belongs or is of the graphics type, and you are going to declare this parameter g. You are going to declare it to be graphics. Okay. So now in this way, you will be able to obtain this parameter, and then you will be able to use it. Okay. So now here what is going on? One thing is very important to which you need to understand. Okay. When you declare it, to be as the graphics, okay, but it is also using, for example, graphics 2D object. So how? There is a type of casting to the graphics to 2D object. For example, this is the first way. Second way is you can obtain the reference to graphics 2D object by calling the method get graphics. And you can write here graphics and then get graphics. This is the method in order to create a reference to the graphics 2D object. So now here the story is we are going to use these methods. Okay, not directly but indirectly. There are two ways to retrieve this graphics 2D objects. Now here you will see what are the methods in graphics class. Okay, it can be AWT or it can be the graphics 2D. What is the class here in AWT? What are the methods in class AWT? These are the methods. Okay, for example, set color, set font, set XOR mode, set paint mode, translate, draw line, draw rectangle, draw oval. These are the ready-made. Okay, you can directly use these methods, but you need to know what are the parameters, okay, and how to use these parameters. If you know it, you can use these methods and you can construct any graphic object. Okay. Now, if we will see about the graphics 2D classes, what are the methods? The methods are, for example, here you can use draw shape, fill shape, you can use the transformation, you can use affine transformation, you can use set paint, you can use set stroke, clip, set composite, rendering, and many things. You will see here we do have extra methods which are not present in AWT. However, in graphics 2D, you can do everything what you are able to do with AWT, but in AWT, we don't have those methods which are present in graphics 2D. And in graphics 2D, we have some methods which are extra, which are more than AWT. Okay, so now let's try to understand the difference between the simple graphics and 2D graphics. Okay, simple graphics means it is using the AWT class, while as 2D graphics means it is using the graphics 2D class. Okay, now if you will see that in graphics, as I told you, we are going to use AWT class. Okay, in this class there is no separation between the modular and renderer. Okay, for example, if we are going to, for example, if we have, for example, we can use a single method in order to, for example, the method draw oval. Okay, you can use it to draw, for example, a shape, and it is responsible for two things: modeling and rendering. Okay, you can draw, for example, the ellipse. Okay, and you can use it for both for defining as well as for drawing. While as in graphics 2D, there is a separation between modeling and rendering. So what does that mean? It means first of all you need to define the shape, and then you are going to draw it by using the draw method of the renderer. Okay, so first you are going to define it and then you are going to draw it. Now see here what we are going to do. We are going to write a simple Java 2D program, okay, which is using the graphics method. Now see here, I'm going to use the paint component here, okay. From the graphics class, I'm going to declare here G variable as belonging to the graphics class. Then I am going to superimpose the paint component to G, and then I am going to use its method. And these methods are actually the methods of this graphics class. What is the method? Draw line. Okay, draw line. This is the method. Okay, if you will see here, we do have these methods. You can see here, draw line will be also one. Draw line is also one method of graphics. Okay, So now here you are going to present the initial point, and then this is the final point. Okay, between these 2 points you are going to draw a line. Now let us suppose that how we are going to draw it. Okay, have a look here. This is your device space. Okay, in device space, this will be your origin of the coordinates. That means 0, 0. Okay, so now if it is 30, 30 means towards x you will move, for example 30, it is here, and then you will come 30, for example here. Okay, this is now 30, 30. So where we are going now, from 30, 30 we are going 230. So that means x is changing from 30 to 200, but y remains the same. So this point will be 230. After that, where we are going, from 230 we are going to 30, 200. Okay, so what is changing here? What is changing here? Y is changing. Okay, x remains the same. X is 30 here. Okay, so here let me say, for example, x is 30, but y is 200. So that means I am coming here. Okay, and then from this point I am moving to another point which is 200, 200. So that means here y is 200, x is 30. X is going to change. This will be now 200, 200. So, and then from here I'm going back from 200 to, you are going back to the 30, 30. 30, 30 is here. So the picture will be like this. Mahmoud. This will be 30, 30 from the 30. This will be 30, 30, 200. Understand? Do you have any question here? Such examples will be in your exam, in your midterm, in your final exam, as well as in the TMA. You need to construct, for example, any shape based on the coordinate system. Or for example, if I will say you, for example, you need to make, for example, a shape like this. Can you do it? Or you need to make a shape, for example, like this. Okay, so what you need to do, you need to think about the coordinates and then use the draw line and then make this shape. Okay, these shapes, such shape, you will be in your exam, you will be asked to draw shapes like these. Okay, what you need to do, it is very simple. You need to use the draw line of the graphics class, and then keep in view the coordinate system, the initial point and the final point of the line, and then draw the lines. Can you do them? If you have any question, just ask. No any question? Hello? Okay, so here you can see the output of this program is here. Okay, it will be the same output as I told you here. Okay. Okay, try to understand this picture. If you have any question or any query or anything you want to ask, you can say me. Okay, because this is important for you to understand these questions so that you can do them in your exam. So, do you have any question? Now see here. See here what we are going to do. This will be, these programs will be in your midterm as well as in final. Okay, so try to understand what we are going to do. This is another example, example 2. Here we are going to have a simple 2D program by using the graphics 2D methods. Okay, so always you need to remember that you need to use pen component of the graphics class, and then here I am going to declare now G2. Okay, G2. Okay, of graphics 2D class, and then I am going to use a type of casting for G. G belongs to the graphics class, and I am going to convert it to graphics 2D. In graphics 2D, you can set the color. Let me suppose that
Doctor, there's no sound.
hello? Do you hear me?
Yes, we can hear you now.
Okay, I think there was some interrupt. So regarding the previous slide, do you have any question here? Any question? Any question? Okay, so I'm explaining you now this program. Okay, so here what we are going to do, we are going to use graphics 2D methods. Okay, as I told you that in graphics 2D we have some extensive methods. For example, if I want to draw a shape with any color, for example, I need to define here the color. So I'm going to define here the color.blue. That means the color will be now blue in order to draw the shape. Now I am going to define the shape. Which type of shape I want to draw? I want to draw, for example, ellipse. Okay, I'm going to define it as, declare it with the variable e, and then I define it. It will be a new object of ellipse 2D, which is with these coordinates. Okay, that means 100, 50, 200, and 100. Okay, this is the initial coordinate, and this is the width and height. After that, I am going to use the affine transformation by declaring it as TR. Now, what type of transformation I am going to apply here? There are different transformations. There is scale, there is rotation, there is transform. There are different transformations. But I am going to apply here one type of transformation. I call it rotate, because this is the rotation transformation. So what we are going to do here, I am going to take this ellipse and apply the transformation, which is rotate. Okay, how I am going to rotate this ellipse? Okay, I am going to use here math.pi divided by 6. Okay, so what is math.pi? Do you know what is pi? If you will see pi here, it is equal to 180 degrees. Okay, so now if you are going to divide it by 6, I think it will be about 30 degrees. So what is the meaning here? The meaning is, from this statement, you are going to rotate the ellipse by 30 degrees. That is it. Mafhum? Do you understand it?
Yes.
Okay, so in this way, we are going to rotate this ellipse by 30 degrees by using the affine transformation. Okay. Now where I'm going to apply the transformation for the shape, which is E is for ellipse, which I have defined it here. And then I am going to use translate. Translate means it is going to move it to another coordinates, which is 300, 200. And then I am going to use the scaling. Scaling is, for example, 2, 2. So that means it will be from both sides, it will be the same. Okay. And then I'm going to draw the shape. Okay. Draw shape means the shape which is here in a transformed shape. Okay. And then I'm going to draw a string in which I'm going to write hello 2D, and then I'm going to show the coordinates. Okay, 0, 0 means the original coordinates of the shape. If you will see here, this is the origin. So this is the origin. Okay, on this origin, which is, for example, 0, 0, I'm going to draw here a string which is hello 2D. Okay, if you will see here, this ellipse, it has been drawn in blue color. The string also in blue color. Why? Because initially I set the color of the pen with the blue. So this is the color for the pen. Okay, so this is blue, this is string at the center with the coordinate is 0, 0. And here this ellipse, if you will see, it is not kind of like this. It is not like this. Why? Because I am going to rotate it by 30 degrees. Okay. How you are going to rotate it? By using the affine transformation. There are many methods. I am going to use the rotate. And then you need to define, okay, what is the angle? Angle, it can be any angle. Okay. For example, here I am going to use 30 degrees. What is the way? The way is, if you want to use pi, pi is equal to 180 degrees. Pi is actually within a class, that is math class. You need to define it, math.pi divided by 6, then you will get here 30 degrees. Okay. That is it. In this way, we are going to work with these transformations, with these 2D graphic objects. If you have any question, please ask. Now, let's give you, for example, this exercise. Okay, let us suppose that in your midterm or in final exam, you need to write a program. Okay, to draw this digit 2 in this way. Okay, so what you will do, you will start from this point. Let's suppose there are coordinates, some coordinates, and then you need to find the coordinates of this point. Let me say, for example, here the coordinates are 40, 40. So what can be the coordinates of this point? What will change? Which coordinate will change here? What do you think?
X.
Yes, X will change. Let us suppose that then here it will be, for example, let me add it, for example, let me make it 100, 140, and Y will remain the same. So, okay, so now here, every side we are going to add, for example, 100 in order to make it easy to understand. So what will be the coordinates here? What is going to change here now?
Y.
Yes, so what will be the coordinates here? What will be the coordinates of this point? X will be the same, 140. Y will change, it will become now 140. So I am just from every side, I am going to add 100 to make it easy. If I will go back to this point, what will be the coordinates here?
x14 and y14.
Y also 14? No, Y will be 114.
Oh,
Okay, what will be the coordinates of this point? What is going to change here?
$40, 280.
Let me say it is 40 and let me say it is 240. Okay, I'm saying, for example, it is 100. Okay, every line is 100. Okay, this is also 100 pointers. This is also 100. Okay, this is also 100. Okay, so that to make it easy. And what about this point? This will be now how much?
114, 214.
Very good. So in this way, you are going to draw these digits. Now let us suppose that I am giving you this digit. Okay. Here in this, you will see here, there are many different ways, okay? Student can draw first this line, okay? And then they will draw this line, or full line, and then they will draw this line, okay? And then in between they will draw this line. Or a student can draw this line, then this half line, then he will go here, and then he needs to come back to this point, and then draw this line, and then go here, Or the student can draw these three lines like this, and then join these lines by one line, okay? So there can be different ways to draw this digit 3, but in all the ways you need to take care of the coordinate system. Is it clear now?
Yes, Doctor.
Okay, now about the graphing equations, okay? We have some mathematical equations which are very important to model actually any graphic object, okay? Whenever we are going to plot an equation, that means we are going to use the simple graphics application. So now here the point is how we will be able to use these graphic equations in order to generate any graphic object by using these pointers of the equation. Sometimes we are going to use also some functions, okay, which are in the form of, for example, y is a function of f of x is a function, and y is a function of x. Here in this case, if y is equal to f of x, that means it is a straightforward function in which the set of x coordinates you can choose the set of x coordinates, and you can find the coordinates of y. Matlab, x is equal to x is 1, here y will be also 1. So you can make a table like this. Here you can write x and y. You will give the values for x and you will find the y. You can calculate the y. Now it depends upon the function f of x and how much it is. F of x can be, for example, matlab equal to 2x plus 1. Okay. Now if x is equal to 1, you can calculate what will be y. Okay. So now if x is equal to 1, 1 into 2, it will be 2, y will be 3. And in this way, you are going to draw these points. You are going to find these points. But sometimes there can be two variables in a function. Okay. Here you will see that we have a function. There are two variables. Matlab 2x plus 3y is equal to something. Okay. So here you are going to use in this function, you have two variables. Now there is something about the Cyprograph. Okay, cyprograph, it is, if you have seen, there is a type of device by which you can draw the pictures like the shapes, like these shapes. You are able to draw in these shapes by like these shapes. Okay, this is a type of device. You just put the pen inside it and rotate the pen, and you can draw the pictures like this. Anyways, we can do the same by using the Java 2D graphics, in which you need to use these parametric equations. In this parametric equation, what is a parametric equation? I told you before, in parametric equation, we do have the third variable, okay? And the third variable is actually t, okay, which we are going to use in any function, for example, f of t. So now the same thing is here. We are going to use here a function that is actually cos t. We are going to use here another function that is sin t. And what are the two variables? X is one variable, y is another variable, t is the third variable in parametric equation. So now in this parametric equation, what we are going to do, if you are going to draw a cyprograph, okay, you must know what is the R1. R1 is the first radius, and R2 is another radius that is equal to 50, and P is, for example, here equal to 70. Okay, here we are going to use one more variable that is actually the fourth variable, that is P, and it can be any constant. Okay, so now here, see how we are going to write it in this program. Always you need to start from the paint component, writing here that it belongs to the graphics class, and then you are going to declare the variable g, which belongs to graphics class. Okay, and then here I'm going to use, for example, this defining the variable g2, okay, which belongs to the graphics class, and converting it by using the graphics class g2 to the graphics. And after that, I'm using translation 200 using a set color which is blue here, okay. And then I'm going to define the variables, the radius 1, radius 2, and p. Okay, these are the initial parameters. Okay, after that I'm going to define other variables in which, for example, n points, it is, for example, 1000 points. X1 is equal to this one, Y1 is equal to this one, and then I'm going to declare only other two variables, X2 and Y2. Okay, and then I'm going to use them, but here I'm not assigning anything. And then I am going to use here a loop. The loop starts from 0 to n points. N points is defined already, initialized here, that's equal to 1000. And every time I will be incremented, and then I am going to write here double t, defining any t, which is I into math.pi divided by 90. Math.pi. So that means divided by 90, that means 180 divided by 90. What you will get? You will get 2. So multiply it by I. So first time I starts from 0, it will be 0, I will 1. So this loop, it is going to run how many times? It is going to run 1000 times, okay? And every time here the t is going to change. And then I am saying here x2 and y2, they will be calculated by using this parametric equation, okay, which we have seen in this slide. Okay, I'm going to use them directly here. And then I'm going to draw the lines. Okay, draw lines from the initial point to the final point. In x1, y1 is the initial point, and x2, y2 is the another point. And then I'm saying that x1 is equal to x2, y1 is equal to y2. So that means if this is the initial point, for example, x1, y1, and this is the final point, x2, y2, when I reach here, okay, then I need to move to another point, okay. So that means x2, y2 will be now the initial point for the next one. And in this way, it is going to continue, okay. It is going to continue, and then if you are going to run it, you will see that you will get a graph like this. This is the output of this graph. See here, if you are going to change the parametric equations, okay, everything here in the graph will change. Okay, if I'm going to use this parametric equation instead of these parametric equations, okay, the shape of the graph will change. It will change from this shape to this shape. Okay. Is here any question?
Yes, doctor, I have a question.
Yes.
The draw line, can we replace it with draw new line 2D dot double?
Well, here, draw line. Do you want to replace it by?
Line 2D dot double. Can we replace?
You can do that, but here we are using this G2. See here, what is G2? G2 is actually using graphics 2D. So in graphics 2D, we have a draw line method. So that's why we are going to use this method here. If you go back here, I told you here in the methods, here you will see that is, for example, draw line. It is not written here, but you can see the method is okay, and then you can use it. You need to use here the exactly in this method in this case. Do you understand it? Hello? Here you need to understand also this cos and sine, okay? Once you will understand them, then you will understand what is going on exactly in this picture, okay? In order to understand this, you need to understand one more thing, the equation of circle, okay? Whenever you are going to draw the equation for the circle, you are using this cos t and sine t, okay? So now, what is this cos t and sine t? If you remember that cos t, it is equal to base beta hypotenuse, okay? And sine t, it will be equal to perpendicular beta hypotenuse. Okay, I think it is written here somewhere. In case of circle, here, for example, see here. What do you understand by this A? What do you understand by this equation? Okay, see here what we are going to do. This is the origin of the graph. Okay, let me call this point. This is x, y. Okay, and you are moving yani, your picture from here to here. Yani, this is the center of the picture. Okay, you are not going to draw it from this origin. You are going to draw it from this origin. So the new origin of this impulse will be x0, y0. So now, how much you are going to move it? You are going to subtract it from here. Okay. In another case, let us see here. Okay. So see here, if you are going to draw it from the origin, it will be like this. Otherwise, it can be like this: x minus x0 square plus y minus y0 square. So what does this mean? It will be equal to r square. Okay. So what does this mean? It means that if let me choose, for example, origin here. Okay. This is the new origin, and then I'm going to draw the circle like this. In this case, if I'm going to move this origin from here to here, and this is the new center of the circle, then in that case, I will write here it is x minus x0 square plus y minus y0 square is equal to r square. Okay, r square. In case of impulse, you need to understand now what is a square. This is same as circle, right? But here, in case of impulse, what is this a square and b square? Okay, a is this portion, okay, and b is this one. Let me say it height, and a should be, as I told you before, a should be greater than b, so that to make it impulse. If a and b are equal, then it will be a square. Now here, the story of sine and cos. Okay. So what is here? For example, if the angle is t, I am saying here cos t, it will be equal to curly black here. B is base, h is hypotenuse, and this portion. This is h. This is b, and this is b. Okay. So this will be here a by b. And in case of sine t, it will be equal to perpendicular, no, this h, no, this is h, okay, and it will be perpendicular by h. So what we define here? We define here, for example, if this is, let us suppose that this is 1, okay, then in that case, it will be a by 1, and here it will be b by 1. So that will be equal, but perpendicular is here our b, okay, because here this perpendicular, it is b, so it will be now equal to b. Okay, so that is why if we are going to choose, for example, the hypotenuse is 1, okay, then in that case we are going to select here a and b with cos theta and with cos t and sin t. That is why here you are saying that for the parametric equation of impulse, we are saying here it is x0 plus a cos t and y0 b sin t. Okay. Okay, anything else you have? Any more question you have?
Doctor,
Yes.
when we have used Java to draw all this,
Again. Well,
or do we have a practical class?
no, in this course we don't have the practical class, only we have the tutorials. Maybe there will be some support sessions. If they open it, then we will have the support sessions. But right now, according to the schedule, we have only tutorial classes bi-weekly.
Okay, so we don't have Java.
No, we have Java. We have already, you have done any Java. You have passed this M105 or Tm240, sir? 105 class, huh?
Yes.
So you know Java, sir?
No, doctor, you understand me. We practice for the draw. This.
You
How?
need to practice it yourself, because here we don't have the late sessions. You know?
Okay.
Yes.
Thank you.
That is what I was actually trying to convey the dean of this ITC for the faculty of computer science, but there is no any output. Okay, you can also request to them for the practical sessions. If they allow, then we can have more sessions. Otherwise, as per schedule, it is bi-weekly, once in a week, once in 2 weeks. So anyways, you need to practice all these examples, and just copy paste these examples. You will understand, and then try to change some parameters, and you will see what is happening in the output. Okay, in order to understand it more. In the same way, if you are going to use this function, okay, you will get a graph like this. So what is the conclusion? The conclusion is, on this parametric equation, you will get a graph like this. If you are going to use, for example, this parametric equation, you will get this type of graph. If you are going to use, for example, this parametric equation, you will get a graph like this. So in 3 different types of parametric equations, you will get 3 different types of graphs. That is it. So here in this way, this is the end of the tutorial for today.